Hey guys, welcome back to day 11 of doing one quantum financing question every day. Today our question is, you and your friend are playing a game where you each pick an integer from 1 to 10 inclusive and add that to your running total. The person that states 50 is the winner. You gotta go first. What number do you say first? This is more like a brain teaser problem, so it's kind of interesting if you think about it, but like usual, I want you guys to possibility and think about this question yourself, and I'm gonna explain the solution in just a little bit. Got a 50. And let's think, because each person can only pick an integer from 1 to 10. This means if the range falls between, say, 40 to 49, then whatever, we can immediately win the game, because we can just add something that's between 1 to 10 to get to 50. So if the number after your opponent says his number falls in the range of 40 to 49, that means you will guaranteed to win. So this means the number you're actually trying to hit after your round is 39. Because after 39, whatever your opponents add would definitely make it fall into this range. And that's how you win the game. So now we can suddenly see that the winning condition of 50 now becomes a winning condition of 39. So whoever gets to 39 will win the game. And if you just repeat the process, how do you get to 39 first? Well, think about what's the range that the number has to be in so it can add something to become 39. The answer is, it could be 29 to 38. Anything in this range, we can just add something just so it becomes 39. So how do you make sure that it becomes this range when after your opponent does something? So we got to make it 28. It's quite intuitive. So now the winning condition becomes 28. So whoever gets to 28 will guarantee the victory of this entire game. And that's the fascinating part. We can just keep doing this and lowering our winning condition. How to get to 28 first? Maybe it has to be between 18 to 27 after your opponent makes a move. So 17 becomes the winning condition. And then how to get a 17, if you see a 6 to anywhere from 7 to 16, then you're pretty much guaranteed victory. So how do you make sure that your opponents, after they add something, becomes 7 to 16? You just got to start with 6. And it's that simple. So just working a game backwards from 50, we can kind of see this trend each time we're subtracting by 11, and that's gonna guarantee our victory. So even though this game is not fair, so whoever goes first will almost certainly win the game, because the person can just say the number that guarantees victory in this case. But we can kind of generalize this solution to a wider range of numbers. Forget about 50. Let's say the number we're trying to hit is n. And what is the winning condition? What number should we start at? Okay, so we know, each time we subtract 11. So for positive integer x, whatever x, this is a multiple of 11th, and whatever is left should be the number we start with. And this could be written as the formula n modulus 11, which is basically when n divided by 11, whatever the remainder is the number we're looking for. So in the case of 50 mod 11 is 6, because 50 minus the biggest multiple of 11 that's smaller than 50 is 44, so it's equal to 6. So generally our solution will be n mod 11. So you can actually see that only case that your opponent's gonna win, or whoever goes second within the game, is when n is exactly a multiple of 11. So it could be 11, 22, 33, 44. This is because the only way you can win the game if you go first when n is a multiple of 11 is that you have to say 0. And we know you couldn't say 0 because you have to say something between 1 to 10. So your opponents can just say anything and just add to 11. So your opponent will basically guarantee the victory. But most likely, you're going to be guaranteed to win most of the times. So yeah, that's my solution for this problem. If you enjoyed it, please drop a follow. And come back tomorrow for day 12. Thank you for watching.